welcome everybody today. API security testing requirements for PCI, SOC 2, CCPA, and other compliance frameworks webinar is hosted by Truvantis and APIsec. APIs have become a primary target for hackers looking for logic flaws that can provide direct access to sensitive data. All security frameworks start with a risk assessment and require regular vulnerability and penetration testing of both networks and applications. However, a few compliance regulations specifically mention API testing. We will today review various security compliances, regulations, and frameworks such as PCI DSS and SOC 2, and share how APIs are currently covered by security testing requirements. I'd like to introduce both the panelists who will be speaking today. Matthew Corwin, who's VP of Security and Privacy Risk at Truvantis. Matthew Corwin is an attorney and a consultant specializing in privacy and cybersecurity. As an expert in privacy compliance, enterprise risk management, data protection, enterprise data architecture, data governance, and MDM, he leads corporate risk management and compliance programs while facilitating business growth through technology business alignment. Your other speaker is from APIsec, Dan Barahona. He's VP of Marketing and Business Development. Dan has held an executive level role spanning products, business development, and marketing over 20 years at cybersecurity firms, including ArcSight, Qualys, Anomaly, and others. At APIsec, Dan leads the company's marketing and business development efforts and is responsible for partnerships and channel. Dan holds engineering degrees from Cornell University, Rensselaer Polytech Institute, and an MBA from the University of Michigan. Before I turn it over to Dan, I'd like to remind everybody that both Dan and Matthew will be taking questions today, so please continue to post questions throughout the webinar. And now I'd like to turn it over to Dan from APIsec to kick it off. Dan?
Great, thank you, Sumita. Thank you all for joining. Really excited for this session, actually. I hope you are as well, and thrilled to have Matt from Truvantis joining. APIs are really a hot topic these days, seem to be in the news almost daily, and I'm really looking forward to learning about compliance requirements and other implications of APIs and how to secure them. So diving right in, I thought I'd open up with a few slides before I hand it off to Matt to dig into more of the compliance side. So as I'm sure everyone on the call is well aware, APIs are truly everywhere. They've really transformed how we build and run and manage our applications. The functionality has really opened up entire new business models for organizations to be able to enable functionality, to extend their platforms, to enable integrations and all kinds of wonderful things. And fully, 80+% of the internet traffic now apparently is actually API traffic. So it's really, quite pervasive. And of course, along with that comes the flip side, which is that, hackers have paid attention to this trend as well, and have really targeted APIs themselves as the next frontier for breaches, for data theft, and the like. And this quote from Gartner quite telling, by next year, not that far away, the #1 most frequent attack vector for breaches. And it's sort of not too surprising when we look at, what APIs do today. Is they really are this sort of central point that manages all the communications between our web apps, our mobile apps. We now expose those APIs externally to partners and clients and the world at large. Internally, they're used to power microservices and containers, and they are the conduit between all these layers and the back end, where the data lives, where the functionality exists, and the like. And so if there are any flaws here at the API layer, that can turn into significant breaches and risk for organizations. And not only do they provide a great deal of access, but what we find is these APIs are often over permission and under secured. In the rush to push new functionality out and features and releases, it's not uncommon for these APIs to have logic flaws that exist within them. And these logic flaws are what hackers are looking for. They're discovering that this is the single most profitable, most fruitful target for actually harvesting data, for gaining access to unauthorized functionality, and the like. And this was borne out in the news, and I'll walk you through a handful of examples. Postal Service had an API that allowed shippers to access their shipment information, packages in flight, what address are they going to, who signed for them, estimated time of arrival, and so forth. Turned out somebody discovered that they could manipulate the parameters and increment an ID by 1 digit, for example, and now they were looking at somebody else's shipments. So they simply iterated through 60 million combinations of IDs and harvested all that information, all through the API. We've got Peloton just last week, 10 days ago, totally unsecured API, gave unrestricted access to all 3-4 million subscribers, including to subscribers who had marked their data, their profiles as private, all through that API. Venmo, which had a feature on the homepage that showed the last 20 real-time transactions. Someone figured out that that was leveraging an API call to the back end, tried it out and discovered they could query that API directly, and simply wrote a script to iterate through that 100,000 times a day, harvesting 200 million transactions with full details, every record, all of the private information and the like. At Instagram, if you ever forgot your password, you could actually request a reset through the API. It would send you 6-digit code. And it was clever, right? They had a 10-minute timeout. You could only guess 200 times before it would lock you out, but did not restrict how many IP addresses you could use to make those requests. So someone built a farm, simply iterated through 200 guesses per IP, and just continued until they were able to take over any account of their choice. And then Bumble is the last example here. The issue here was not only could this person access all the records in Bumble through the API, but he could even manipulate them. He could turn on premium features and remove restrictions and the like. And the reason to go through all of these examples is not just to highlight that this is happening for real. All of these are sophisticated companies with sophisticated security teams, and yet these breaches happen. And what we're seeing is that this is a different kind of attack, right? It's not classic, common vulnerabilities or SQL injection attacks or cross-site scripting or things like that, right? These are all leveraging unique flaws in the application logic for each one of those organizations. It's almost like their own personal 0 days were identified. And these types of breaches or vulnerabilities require a different approach. And so that's what we're going to talk about here today. And I'd like to invite Matt to share with us. Let me get Matt, if you can share your screen. Love for you to dig into some of the compliance and risk framework implications here for APIs as organizations are looking to really address not only the security, but to maintain their compliance postures as well. So
yeah, thanks, Dan. Thanks for that. That was a great intro and a great kind of summary of the state of play out there for adversaries that are trying to exploit these APIs. So yeah, I'd like to just sort of jump into this, talk about the compliance requirements. So I think I've heard, I know Dan's heard, a lot of us have heard, well, I'm looking at my compliance framework. I'm looking at the regulation, the regulatory requirements. I don't see it says API security anywhere in here. So is that something that's really required? And so we'd like to talk about that today, considering that, as Dan just showed, there is certainly risk out there. So API security for compliance, we're going to talk a little bit about risk assessments, how those factor into compliance and where APIs fit into that. We'll talk a little bit about privacy, including CCPA and GDPR, SOC 2, PCI DSS, and then OWASP, and that'll lead kind of right back into what Dan's going to talk about next. So risk assessments. Most of you probably have to perform a risk assessment as part of your organizational security exercises, probably at least annually. Most security frameworks require a risk assessment. We'll talk a little bit about what privacy says about this in a minute. But this, just as an example, is the NIST 800-30, which is a pretty standard risk assessment process. You're going to talk about threat source, threat event, your assets, how those assets might be vulnerable to those threat sources and threat events, and what the impact might be, probably with a likelihood factor built in. So when we talk about this, we know that those threat sources, threat actors, threat events are out there. We just saw 4 really great examples of how threat actors are targeting large multinational corporations with API logic flaw attacks. And so we know that that threat event happens. And if you're running APIs, then you at least need to address the potential vulnerabilities and predisposing conditions you might have with respect to your APIs and those logic flaw attacks. Otherwise, your risk assessment's incomplete. And we also know that APIs inherently expose logic and sensitive data. So if you're using those APIs to manipulate sensitive data, transmit sensitive data, move sensitive data around, or they just have access to that sensitive data, then those APIs, again, need to be part of your risk assessment. When we talk about privacy, so CCPA says you have to have reasonable security. GDPR requires that you have appropriate security. I think they basically mean the same thing. And fundamentally what they're saying is you need to take into account the risk profile of your organization, the threats that are out there, the sensitivity of the data you're processing and the impact it would have on people, as well as the volume of data, and come up with an appropriate set of controls that address that risk in a reasonable or appropriate way. And again, that looks a lot like a risk assessment for most organizations. And it also includes applying industry controls, and we'll talk about that a little bit with OWASP and PCI and SOC 2. But again, if you use APIs to access personal information, transmit, process personal information, then that's going to be part of your risk assessment, and you're going to need to determine what controls are appropriate. Or in other words, how are you addressing that risk that attackers that we know are out there trying to exploit those logic flaws and those vulnerabilities? How are we addressing that? And don't forget consent as well, because if you're using APIs and there's data that's being moved around in ways that you're not fully aware of, if you're not tracking and mapping that, then you're not necessarily capturing appropriate consent for that movement of personal information. SOC 2. So the SOC 2 report is obtained after a third-party evaluation of the design and operating effectiveness of the controls relevant to security, right? We know this. It maps to ISO 27001. In the US, I'd say this is pretty much the de facto security certification standard for most organizations that aren't dealing with government contracts and things like that. And if you look at the requirements, again, you're not going to see it say, hey, do API security testing. That's not there, but it also doesn't necessarily talk about specific network controls. It doesn't say you have to have a Palo Alto firewall, or you have to do any particular thing with a particular type of application that you might have developed. But what it says is you have to restrict logical access. You have to restrict access to information assets. You have to conduct vulnerability scans that are at least capable of discovering the vulnerabilities that exist. You have to protect confidential information. It's pretty high level, but again, if you know that you have APIs that process, have access to sensitive information, you're not compliant with these controls unless you've implemented some sort of security control process, some sort of vulnerability assessment process that's capable of recognizing where those vulnerabilities might exist and giving you a mechanism or a venue to change those controls and improve your security with respect to those APIs. In other words, complete that remediation. Now, PCI DSS, we're getting towards, I think it's a little bit more obvious that they're saying, hey, you do need to address these APIs. PCI specifically says all security vulnerabilities using reputable outside sources for security vulnerability information. And again, vulnerabilities is not just things like cross-site scripting, it's any kind of vulnerability of that application, which as we've just seen can definitely include logic flaws. So PCI also says addressing common coding vulnerabilities, and it refers to OWASP. And if you actually look in the PCI DSS, the data security standard, it's going to say, this is the current, it enumerates some things from OWASP. And it says this is the current kind of state of the art in terms of security vulnerabilities that you need to look for. But you also need to see what the latest standards, see what's coming out, see what industry experts are saying, and incorporate that into your assessments. And actually, OWASP has come out with a API security top 10 specific for APIs, which is still part of OWASP. And again, OWASP is specifically referenced in the PCI standards. So you need to take that into account if you have APIs leveraged in your organization and your applications. And we'll talk a little bit more about OWASP. And again, for public-facing web applications, you need to address new threats and vulnerabilities on an ongoing basis. That's another way of saying the same thing. So if we know there's threats out there that are exploiting API logic flaws, you're not compliant with PCI DSS as a QSA. I'm not going to sign off on your ROC unless you've somehow assessed all of the vulnerabilities that are potentially exposed through an API. And that's got to include logic flaws. And again, we'll look at OWASP API security. This is the top 10. And you'll see APIs. What they're looking at here is not just something like injection, which is over there on number 8, but they're also looking at broken object level authorization, broken user authentication. And again, I think Dan's going to cover this a little bit more thoroughly with some specific examples, but these are the kinds of things that just looking for basic vulnerabilities that some of the tools that might have been used a few years ago would help you find is not going to be sufficient to address the risk going forward, considering the kind of attacks that are happening right now with APIs. All right. And with that, Dan, I'd like to invite you back on. I think you're going to talk a little bit more about OWASP and compliance, and then start talking about, okay, so how do we address these risks? What are the solutions that are out there?
Yeah, absolutely. Thank you, Matt, and really appreciate that overview. It's really interesting to see how these frameworks and compliance requirements connect to APIs. It's not always black and white, and yet the requirements are still there. So we'll talk some more about that. And to build on your last slide about OWASP, and we'll just focus on the top 5 here, right? Because this is where we're actually seeing those unique API-oriented threats. And in fact, I'm pretty sure OWASP has rank ordered these in terms of like the severity, the potential for damage, or the frequency of breaches that we're seeing. For OWASP number 1, broken object level authorization, in plain English, we're talking about, can user A access user B, right? Are there authorization issues that allow access to data that doesn't belong to you? And in fact, that's exactly what the Postal Service example was, right? Through that API, someone was able to manipulate the query, access data that didn't belong to themselves, and then maliciously harvested 60 million different users' account information. OWASP number 2, broken user authentication. This is really all about policies for authenticating. You know, are there strong password? How do you do resets? Is there authentication at all? And this is, you know, an issue that drove the breach at Peloton, or the exposure at Peloton, right? It was an unsecured API endpoint that could be queried without authentication, and that gave access to pretty much the entire user database. OWASP number 3 is excessive data exposure. So this is really addressing the question of, you know, does the API deliver more than the application requires, right? APIs are simply function calls. They will return whatever they are instructed to fetch. Now, in the case of Venmo, the homepage that they wanted to populate only needed to have high-level, information without any identifiable information and the like. However, the API that powered it would simply fetch the entire record, the user details, the transaction details, all of that information. So this is a great example of excess data exposure, right? The API was providing more information than was necessary to satisfy the requirement. Number 4 is lack of rate limiting. So this is really, you know, kind of denial of service type things, but also, you know, are there any ways to ensure that the API is not being allowed to deliver, you know, vast quantities of information in unauthorized ways? And that's Instagram, right? So that API, if you wanted to reset your password, it would limit you to 200 guesses, but did not limit the number of IP addresses you could guess from. And someone literally tried on thousands of different IPs till they were able to fetch or to guess the correct reset code. And then the last one, broken function level assignment. This is really, dealing with what kind of operational capabilities do you have. So, for example, it's one thing to be able to view your invoice, say, from a vendor. It's another thing to be able to delete the invoice, or to edit the invoice. And that's what the issue was at Bumble, right? Not only could they access these records, which was its own issue, but this person was able to manipulate and modify records. And that's what we see here. So hopefully that kind of brings the OWASP a little bit down to closer to earth and to reality. And so building on some of the other conversation from Matt, APIs have huge implications for privacy. And here we're talking about things like GDPR and CCPA, HIPAA, pretty much any regulation where the goal is to protect the private information of individuals. And all of these regulations mandate that. And as Matt pointed out, they don't say you have to use X, Y, or Z type of technology. They really specify the objective, which is that this information needs to be secured, protected, and to make sure there's no ability to harvest. The issue with APIs, of course, is if there are flaws in the API, they are incredibly effective at harvesting data. As you saw, the 60 million from Postal, or the 200 million from Venmo, or 500 million from Facebook recently. So that risk assessment that Matt talked about is critical. And if you have APIs, and if those APIs have access to any type of PII, then you need to consider your implications for GDPR, HIPAA, CCPA, and other privacy regulations, and make sure you have controls in place to ensure that your API is not able to give access to unauthorized users to large volumes of data, or to anyone's data that doesn't belong to them. So that's privacy. For compliance, Matt went through PCI in better detail than I can, so no need to repeat that. Open banking is another example. So in the banking space, open banking in Europe requires interoperability among financial institutions and with third-party providers to enable that exchange of information in a seamless way. It actually goes on to mandate the use of APIs. But here's that sort of double-edged sword. So on the one hand, it requires the use of APIs, and on the other, you have to make sure that those APIs don't become a conduit for breach. So this reinforces the need to ensure that those APIs are highly vetted and secured, and as Matt pointed out, not just from common vulnerabilities and injection type of attacks, but from those logic flaws that can lead to these types of breaches as well. And we'll talk a little bit about how we can actually go about finding those. Two more real quick. The CMS Center for Medicaid and Medicare and Medicaid Services for healthcare, there's a new standard called interoperability, which mandates the free exchange of information through APIs again of healthcare data, so that patients can easily port their data from one provider to another, or to an application that they choose to use. So again, really mandates the use of APIs to enable that type of exchange. But of course, you have to make sure that information remains private and secure. And then lastly, FedRAMP for any cloud-based providers that sell to the government. This is perhaps the most explicit example that I've seen for API monitoring. It actually states in the vulnerability management document under RA5 that all web interfaces must be scanned monthly. That term web interfaces can cause confusion. Does it or does it not incorporate or include APIs? I've spoken with the GSA, the Program Management Office, who confirmed that it does, in fact, include APIs. And so really, truly, if you've got APIs, if you're FedRAMP compliant, you need to make sure that those APIs are getting scanned on a regular basis as well. So how do we go about doing this, right? And securing the API lifecycle, there are things you can do at various stages, whether it's design, test, in production, and the like. And if as you've seen here, there are different types of vulnerabilities. There's the classic vulnerabilities we're all quite familiar with, things that have CVE numbers, or injection type of attacks or cross-site scripting. And there are many tools that exist, whether it's at design time, like static analysis or dynamic analysis for test time, and firewalls and gateways and the like. All very well known and mature products that can help you find those security vulnerabilities. But when we're looking for those logic flaws, that's when our options get a lot narrower. At design time, it's very difficult to find these types of flaws. You really need a full functioning application, not a set of code. And so that makes that tricky. Or in runtime, where you're looking at traffic, you're looking at a URL or a request, there's really not a lot of context there to be able to decide, is this, is Dan accessing his records or is he accessing Matt's? There's not a lot of visibility there. So that really leaves you with test time to be able to identify these types of flaws. And the state of the art there is primarily manual. We're looking at pen testing and red teams and using tools like Burp and Zap, which are all effective, but you run into scale and speed and coverage issues. If you're releasing code on a weekly or even daily basis, how you can't run a pen test every night. So, and of course the objective here is to find these types of vulnerabilities before they ever make them into production. And as my good friend Corey Ball, author of Hacking APIs and a pen tester by trade, I think he puts it very succinctly. If you design an API that's ultra secure but don't test it, then some cyber criminal is going to do it for you. And it really reinforces how important and how critical it is to actually properly test and vet those APIs, not just for security flaws, but for those logic flaws. And a little plug for where we fit into the world at APIsec. So this is what we do. We're an automated API test platform. So what we'll do is actually analyze APIs, understand the logic flows, craft hundreds or thousands of tests covering all of the OWASP, and really give you that continuous visibility, that continuous coverage, so that you can make sure that these APIs are secure before they make it into production. And with tools like this now available, you actually can look for not only the security flaws that we've known and understood for a long time, but now even those logic flaws that are really so critical, and as we've seen, have been the source of so many breaches. So, what does that look like in practice? That means having the ability to run a really wide array of different types of attack types. Things like attribute-based access control, ABAC. This is how you're going to find things like OWASP number 1, broken object level authorization. So these are tests to evaluate, is there any permutation or combination or any loophole in the API that will allow user A to access user B. Or authentication exploits or unsecured endpoints, right? This is to address OWASP number 2, or what happened with Peloton, right? Are there any endpoints that are exposed that give access without any authentication or with exploitable authentication? Or data exposure or sensitive data exposure, things like what happened to Venmo, right? Tests that can evaluate these types of things, or rate limiting, OWASP number 4, a role-based access control, as well as all of the common, injection and cross-site scripting and DOS type of issues. And so you quickly could see how, if you're really going to properly vet APIs, doing a pen test every few months or twice a year is really going to have a hard time keeping up with the pace of development. As we know, developers are producing releases almost daily, if not more frequently. And then you look at the coverage that's required to be able to actually look at all of these different threat vectors, all of these exposures, all of these ways in which APIs can get breached. And that's really where automation is so critical, right? We need security to keep pace with DevOps, but still maintain that level of coverage, of visibility, and automation to make sure that you're able to make sure all of these APIs are secure before they make it into production. So with that, I really appreciate all of you sticking around and listening. I invite Matt to come back online. We do have a special offer here for everyone that's on the webinar. If you have APIs, if you'd like to see what their condition is today, we're happy to do a free assessment for you. You can simply go to that URL, apisec.ai/freetest. It's actually quite a simple process to onboard your API, and we'll actually run all of the OWASP category tests against it, give you a full report back, and happy to have further conversations with you. So with that, thank you again. And Sumita, do we have any questions from the group?
Yes, we do. We have quite a few questions. So the first question is, if an API is used for desktop application, but it is taking script XSS when tested through burp, do we still need to worry? Are there no web UI to interact with the API?
Could you just repeat that again? I think I got a little bit lost halfway through.
Yes, no problem. And so the question was, if an API is used by desktop application, but it is taking script XSS when tested through burp, do we still need to worry, as there is no web UI to interact with the API?
Yeah, I think the answer, I'll take that one, Sumita. I think you do, right? An API does not require a desktop interface or a web interface or any interface to be called. So if that desktop application is using an API, then the concern is, can that API be called from another source? Perhaps it's got controls in place to ensure that only certain source can request it, in which case that's a safe, secure API. But that needs to be vetted, right? And so if that API exists, we would recommend that you put it through a process like this to ensure that there are no ways in which that API can be manipulated or exploited or misused. Because if you look at all of those examples, all of those breaches, those were APIs that were being used in ways that were unexpected, that were not the intended use for that API. And yet the API served, responded to the request, delivered data that was not authorized. So the fact that you have a desktop app using an API does not mean necessarily that that's the only way in which that API can be called and in which that API can respond. So I would definitely consider testing that API as well.
Excellent. The next question, where do you map IDOR within OWASP, or is it already mapped?
Yeah, I'll take this, Matt, unless you have some comments, but it actually, IDOR is basically the same thing, or functionally the same thing as OWASP #1, broken object level authorization. So, basically it has to do with, are there, sort of object identifiers and the like, and really deals with access controls and authorization. So, where you see IDOR for web application in OWASP, you can think of BOLA, broken object level authorization, on the OWASP API top 10.
And I think this is just a second part to the same question. What are the optimal way to address IDOR findings?
Yeah, that's a great question, actually. It's probably above my head, and Matt, if you have suggestions there are lots of guidance out there, right? You don't want to have, you don't want to expose sort of static identifiers to objects behind the scenes and the like. But honestly, for that type of a question, I'd recommend, spending some time with our experts and others out there. Pen testers will absolutely flag IDOR and BOLA type of vulnerabilities, and there are very well understood coding practices that can help you avoid having IDOR type of exposures. But you definitely want to avoid anything that is exposed to the end user that gives direct access to sensitive data on the back end.
Perfect.
Yeah, a lot of times you can address that through access control. But yeah, I think if you'd like to reach out to me by email, we could probably talk about that a little more in depth.
Perfect. We have another question. How current is the data related to breaches? I'm pretty sure how current is the data related to breaches? I'm pretty sure my Venmo app has a privacy setting to keep transactions private.
Yeah, absolutely. So that particular breach was sometime last year, and for sure that vulnerability no longer exists. So these are really used for illustrative purposes. The Peloton API has already been fixed. As it happens, these are often quite easy fixes, right? You can simply add some controls into the API code, and that vulnerability no longer exists. So those I would say every one of those examples has been rather quickly addressed, but the issue is they were not discovered prior to production. They were only discovered when the breach occurred, right? Or in the case of Peloton, when journalists made it known to Peloton. So that really reinforces how important it is to find these vulnerabilities before they make it into production, and to ensure you can actually find and fix them before they can cause any harm.
Perfect. Another question from the audience. What type of scanners? What does scanning APIs mean?
Yeah, I'm sorry, Matt. I'm dominating the responses here.
These are all your questions, so go for it.
All right. Apologies there. But what does it mean? So in our world, it's very much like you think of any other scanner, whether it's a vulnerability scanner and the like. It's basically whether it's something that's hosted in our cloud or that you deploy on premise, it's actually that module that's going to interact with your API. So when our platform crafts these thousands of different tests, those tests get communicated down to the scanner. The scanner actually interacts with your API, and that's done by actually issuing a set of API calls, looking at the responses, following up with additional calls. That API or that scanner may be doing that without any authentication, or it may be actually authenticating to your API to actually run and execute more sophisticated type of tests. So the scanner is actually doing the interaction with your API, and then communicating back with the cloud to be able to do the analysis and additional work.
Perfect. I have a question for Matthew. Who in my organization should own responsibility for ensuring APIs are compliant with security and regulatory frameworks?
That's a great question. So companies must be structured to support risk controls, obviously. And the best practice is a decentralization of that risk management, so that the responsibility is placed in the hands of those most directly involved in the daily operation, the process, the implementation of those APIs. Obviously, the developers need to be involved as well, and you need to have a set of checks and balances to make sure that the controls are actually being applied by those at that level. But ultimately, the responsibility needs to be those that are most directly involved in the implementation, and then you need to have oversight and audit functionality, and hopefully tools like APIsec to scan and understand where that might have broken down, and then you do a root cause analysis and figure out what went wrong and try to fix it.
Excellent. Another question that we have from the audience is, do we need to know all the documentation and policies like CMS, etc., for API security?
I can field that one. So this is a really good question, right? So do you need a highly detailed, documented, specified API in order to have any success doing this type of testing? And with our platform, no, the answer is you do not. It's rare that we run across an organization that has deeply documented APIs. That's always an objective, perhaps, of many organizations, but it's rare to encounter that. So for tools like ours, it's not required. We do, look at documentation or specifications from a Swagger file or an open API spec, or from an API platform like an Apigee, Azure, MuleSoft, and the like, but only for very basic information, right? That doesn't require a deeply documented API. We simply need to know, what are the endpoints? What methods can you, do they support? What variables exist within those endpoints? What information can I supply, and so forth? And that information is easily produced through automation from a platform or from a build process. So it doesn't require users to sit down and heavily document the API. In fact, it's not really all that recommended, because if you rely on that documentation, then you're at the mercy of how good that documentation is in order to find flaws. The way we approach API security is to really pressure test that API in every possible way that we can. So that means exercising every endpoint, every method, trying every role and access control that there is, attempting every type of OWASP category of breach. So you saw on the screenshot there, whether it's ABAC or excess data exposure or authentication exploit, all those different types of attacks need to be tested. And so simply looking at the specification and trying to identify, is this API secure or not, is highly limited. And what we really recommend is this very comprehensive test coverage approach that can find not only the vulnerabilities that you might expect to discover, or the ones that are totally unexpected, that your pen tester might not have dreamt up, for example, and that hackers are out there looking for. So it does not require a heavily documented API.
Perfect. I have another question for you, Matthew. How should the need for rapid development iteration be balanced against security and compliance risk?
Yeah, and I mean, and we've seen that API platforms obviously provide a rich, robust set of technologies and tools that allow for implementation of processes and applications that are useful. And in some cases, it's even mandated apparently by some banking regulations that they're that useful. But they also allow for some pretty aggressive attacks, and there could be some vulnerabilities that, again, I mean, they're basically, I think Dan described it as basically kind of unique zero-day vulnerabilities, and that's really what they are. When you're building these API processes, you're probably unintentionally creating zero-day attacks that are unique to your environment, and so there needs to be a backstop of automated detection and risk management there implemented in order to address that. So I think the answer is, you want to develop at the speed of your business. You want to have that iteration happening as it needs to happen to support the business, but there needs to be a security backstop that keeps pace with that. And it's probably not a manual exercise. It's probably something automated.
Perfect. We have another question. How does APIsec do testing for APIs which are authenticated and has token expiring time of 1 minute or so?
Yeah, this is a good question, and not unusual. We run across this all the time. So we do authenticated testing regularly. So there's a mechanism in the platform to provide credentials. If you're doing things like JWT or timed out credentials, that works as well. We basically have a mechanism to request the tokens, to use those tokens for the testing, and then complete our test in the time that's available, and if necessary, to request a new token. The nice thing about automation, though, is that what we do happens very quickly. So from end to end, from analyzing your API, crafting the tests, and running the tests, we're talking minutes. And so we have a lot of clients who actually integrate APIsec directly into their build process. So if you've got a nightly build, for example, you can orchestrate APIsec using a tool like Jenkins or Hudson to actually take that API, send it to APIsec so we can do a full assessment and then receive the results back in minutes with any discovered vulnerabilities, what the severity of those vulnerabilities are, a severity score, and the like. So you can decide, is this API safe to move to production, or are there some fixes required? So that question we get a lot. How do we handle different forms of authentication? It's absolutely critical for what we do to be able to run the tests that we do. So our platform supports quite a variety of different mechanisms to accomplish the authentication.
Perfect. And Matthew, if you wanted to take this one, can you help me get certification that my app / API is HIPAA compliant?
I'd probably take that one. Yeah, I mean, unlike something like a PCI standard or even a SOC 2, you know, nobody can certify that your app or your APIs are HIPAA compliant. The OCR, as part of the Department of Health and Human Services, as the governing body, doesn't recognize any certifications. There are things out there like high trust, and they're going to look a lot like the standards we looked at today, where they expect you to do an assessment of risk and implement controls appropriately to address those risks and vulnerabilities where they exist. And so just like we talked about, you're going to have some method of saying, okay, well, every time we roll out a new iteration of this API, how do we know that we haven't introduced some sort of vulnerability or logic flaw? And so it could be manual testing, but that's probably not realistic for most organizations. So again, it's a self-certification process for HIPAA. So you need to make sure that you have documented how you've accounted for that risk and how you've put in place controls to identify and remediate that risk.
Dan, I think you may want to take the next question. How does APIsec track the system integration challenge?
System integration challenge. Not entirely sure what that's referring to, but I'll take a guess. If we're talking about how does APIsec integrate with various tools and systems, whether it's an API platform or an orchestration tool or a ticketing system, that all exists within the platform. If the question is more about system integrations, systems that are integrating with each other through APIs, again, APIs are all supported through APIsec. So if you have a system that supports an API, has a set of endpoints that can be called through our system, we can do that. We can analyze those APIs, we can craft those playbooks and those tests, we can cover all of the OWASP categories, plus a lot more, and really exercise it. We do not require a UI or some sort of workflow to be defined. What we're looking for is simply, what is the list, the glossary of endpoints that exist on that API? How do you authenticate against it? What methods do they support? What variables can we supply, and so forth? So if that's, and that's really what APIs do. So if you have systems that are communicating over API, we can take those APIs and actually exercise them through our platform as well.
Excellent. Matthew, you may want to take the next one. What about APIs developed and or managed by business partners and third-party agents?
Yeah, and there's kind of two categories there, I think. One is, APIs that are used by the organization itself that are sourced from third parties or sourced externally. And those, if anything, the need for, security risk assessment of those vulnerability scanning is even greater, because there is an additional element of, we don't necessarily know if there's something not necessarily even inherently in the design of that API, but also just in how it's going to be applied in the use case for that organization. And then there's actually totally third-party maintained applications as part of supply chain risk, third-party partner risk management, and for that, companies have to establish stringent protocols for screening business partners and third parties, probably especially including contracts with provisions that give the organization the right to monitor that third party conduct and potentially perform risk assessments, including automated tools or whatever is most appropriate.
And Matt, I'd just jump in. We actually see organizations starting to really pay attention to third party API risk. And in some cases, we've got, we've talked to organizations that run large kind of ecosystems, partner ecosystems that are, building integrations into their platforms through APIs. And these large, cloud-based providers are now beginning to mandate API assessments and testing for membership in the marketplace, in the ecosystem. Right, and it makes a lot of sense, right? They don't want third parties that have exposed APIs or unsecured APIs. In fact, this is what happened to Experian when one of their APIs just 2 weeks ago was exposed through a third party without restrictions. So it's actually becoming very important to not only assess your own APIs, but the APIs in your supply chain as well.
The last question, and I think Dan, you may want to take this one. In the free test, you are asking for bearer token. How can we give that production token to you? Can you explain how the free API pen test works?
Yeah, absolutely. So thank you for already going to the website. We do ask for just a few ingredients there. What's the URL of the API, the documentation of choice that you want to supply, whether it's a file or a pointer to documentation, and then some form of authentication. Right there, you'll see we have basic auth, username and password. We've got token-based and anything else. So depending on what you have, it sounds like in this case you've got bearer token. We would need that bearer token. If it's a timeout-based token, then we're going to need to actually provide a curl command to extract the to issue the command and extract the token at test time. But we've been through this many times. Our team are well versed on how to support this. So I just say get in touch with us, and we can have a conversation how best to attack or handle your specific type of authentication.
Excellent. I wanted to ask at this point, Dan and Matthew, if you had some closing remarks for the attendees and anything else you wanted to share.
Now, I'll go first, Matt. And, I'm just really pleased that you joined us. I certainly learned a lot. I've known for quite a while that there are pretty significant API compliance and regulatory implications. And thanks everyone for joining. I hope it's been a useful session, and we've educated you a bit about the opportunities, the challenges, and more importantly, approaches to securing your APIs, running a safe and secure operation, and also maintaining compliance. So if there's any interest from any of you to continue the conversation, please get in touch with Matt. You see his email there, as well as me. But really appreciate everyone joining. And Matt, any final comments?
Yeah, I mean, I'll second everything you just said, and just also add that we're seeing the risk in this particular space escalate quickly and dramatically. And I think that as security practitioners, everyone on the webinar, appreciate you attending and taking interest in this. Shows that you're keeping up on it, and just make sure that you are addressing that as you go forward in your security plans.
So we had a lot of requests today for the recording, and we wanted to let you all know that we will be sharing the recording post the webinar. It will be shared both through email and also will be available on both Truvantis and APIsec's social media as well. In addition, we wanted to thank you all. We do have several other questions that were more technical that came in, and we wanted to let you know that people will be reaching out to you to answer those questions. And as Matthew and Dan said, if you have anything you'd like to chat further with us, please do connect with both of them or connect with our organizations. We would be pleased to get in touch and help answer further questions and work with you. We want to thank you all for making time today. We had a very active audience. It's fantastic. And we want to thank you all for the great questions, and have a great day. Thank you so much.